All right, hi, we're back again. So today's objective is to write parallel and perpendicular lines. So let me give a quick definition, then we'll get into the lesson. The definition of parallel lines are two lines in the same plane that never intersect, never cross. That are parallel lines. They must have the same slope, though. And we'll give some examples of this in just a minute, but that's the definition. And then note, all vertical lines are parallel, because if you have a vertical line and another vertical line, they would never touch each other. They would go on forever like that. And that's actually where we get the equal sign from. Two lines that never touch. The idea is that they're parallel, they're the same in that sense. Okay, so here would be an example of some parallel lines. Right here, they have the same slope. As I increase by 1, I move over 1. Increase by 1, go over 1. Same with this line. Up 1, over 1, up 1, over 1. Same with this one. So yeah, they have a different y-intercept. They start at different points, but they would never touch, and so they're parallel, and they're in this plane here. Okay? Cool. All right, so let me give an example over here. Get into today's lessons. Determine which of these lines are parallel. How do we determine if a line is parallel? Is this line, and this line, and this line parallel? Well, they look like they are. It doesn't look like they're going to ever touch. But to know for sure, we need to find the slopes. Because remember, going back to our definition, that parallel lines must have the same slope, the same m. So we can find out, though, by using that famous definition, or formula for slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1 equals m. So let's go ahead and do that, and we'll determine if they're parallel or not. So looking at the first one here, we'll do right here, and I'll just designate this as my x1 and y1, x2 and y2, and it's arbitrary. This could have been my y2, this could have been my y1, it doesn't matter. So we'll start with negative 4 minus negative 5 over negative 3 minus 2. Let's see what we get here. Well, we know that a negative next to a negative is a positive, so it's like a negative 4 plus 5, which would be 1. And then a negative 3 and a negative 2 would be a negative 5. So our m is a negative 1 over 5 for this line. But to be parallel, this would also have to have the same slope. So let's find out. We'll do it again. I'll scoot over a little right here. We're going to use the same definition. And so y2, I'll just designate this as my y2. Negative 1 minus nothing, easy, over 1 minus negative 3. A negative 1 take away nothing is just a negative 1. And negative 1 plus 3 equals 4. Well, they actually don't have the same slope. So this line is not parallel with the other line. And so now looking at this top one here, it has a negative 4 and a 3, but it's not telling me what this one is. But that's okay, because I can count. So let me do that really quick. The x is over 1. You can see I'm equal with it there. And the y looks like it's going up 2. Okay? And so the other point is a negative 4 and 3. What do you think? Is this going to be parallel with any of these? Well, let's find out. We use that same formula, y2 minus y1 over x2 minus x1. 2 minus 3 is a negative 1. A 1 plus 4 is 5. It's a negative 1 over 5. Actually, a negative 1 over 5, I hope this isn't confusing drawing this line, is what we had the first time. So A is parallel with C. They all looked parallel, but only two had the same slope, so only two of these lines are actually parallel. Okay? Now, let's scoot over a little bit over here. And sometimes they don't give you the graph. Sometimes they just give you the points. And they'll want to know, are 2 points parallel with 2 other points? You just do the same thing we've been doing. The y2 minus y1 over x2 minus x1. And we would get 35 minus 20 is 15. Negative 1 minus nothing is a negative 1. That would be, the m would equal a negative 15. Let's see this one real quick. y2, oh, it doesn't matter. Yeah, we can make this be the y2 this time. y2 minus y1 over x2 minus x1. and we get 5 minus 10, which is a negative 5, and then 1 plus 2, which is 3, uh-oh, they're not the same. They're not parallel because they didn't end up being the same. This could be asked in several different ways, but another common way to ask, and this is the easiest way, is right here. Are these lines parallel? Well, I can just look, and that's when it's in the slope-intercept form. I can just look at it. They have the same m. They're parallel. Remember, it's going to be in the y equals mx plus b. As long as the m is the same, it's parallel. There's no real work to do. The only time that you could have work is if they try to trick you by putting it in standard form, something like 3x plus 4y equals 12. You may not know right away if it's parallel or not. You would first have to solve for y. And so in this case, I'd have to do a negative 3. So let's look at this equation real quick, and let me ask you, is that parallel with this one? Y equals a negative 3 over 4, x plus 2. Well, I don't know if these are parallel yet, because this is in slope-intercept form, and this is in standard form. So we just have to solve for y, and we can answer that really quick. Negative 3x and negative 3x. These cancel out. Bring down the 4y equals a negative 3x plus 12. Whoops. And then divide both sides by 4. And then we get our answer here. Let me erase this. Which is y equals a negative 3 over 4x plus 12. Well, the slope is a negative 3 over 4. The original slope over here was a negative 3 over 4. So yeah, that one would be parallel.